Alright. Now we proceed. First thing we did was the magnetic lines of force, magnetic field due to a straight conductor. Now we proceed to the next level. Magnetic field due to a circular loop. Remember that the current has to flow through this, and therefore they have to be made of some conducting material. So I have here a wire which can carry current. I can make a circular loop out of this, right? And I can, as before, try to put it on the wire on a cardboard such that the current passes through it and the plane of the conductor is perpendicular to the plane of the wire. Let me explain. Is perpendicular to the plane of the cardboard. Let me explain how it happens. I'll just show it to you in a second. Here. Okay. Can you see it? Yeah. Here it is. Now you will perform. This is a circular coil. Okay. And I have placed the cardboard in exactly such a manner that the plane of the coil, which is like this, is perpendicular to the plane of the cardboard. Why do I keep the cardboard like this? Because I am going to put iron filings on this. And remember that this coil will have two ends, and the two ends will be connected to the battery and to a resistance and back here, so that the current flows through this wire. Okay, and we will find out in what direction is the magnetic field produced and what about its magnitude. Okay, so how is this situation different from the magnetic field due to a straight conductor? Okay, now what happens is this, that this small, you perform an experiment. Again, I will draw the diagram to show you the conductor. Okay, you have to imagine that this part is coming out and this part is going in. Okay, so this part is going in and this part is coming out, and this is the center of the coil, and the center of the coil, see, center of the coil lies on the conductor, and you have iron filings here. Now you connect the two ends to the battery. Connect the two ends to the battery. A variable resistance or a rheostat, add a key, complete the circuit. So from here the current goes this way, goes down this way, comes up like this and like this. Alright. Now what happens? This part, in fact all parts of the coil act like small straight conductors. They all produce their own magnetic field. And you can see, just now I will show it to you, that the magnetic field produced by each flat part, each straight part is in the same direction. So the magnetic field produced by this portion, by this portion, by this portion, all these portions is in the same direction, and therefore it gets added up. Let's come to this. Here suppose the wire is coming up. If the current is coming up, wire of course is coming up, but if the current is going like this, the current is coming up, how do I apply my right hand thumb rule? Imagine the current coming up here. Okay, imagine I am holding the hand in such a way that my outstretched thumb is in the direction of the current. The magnetic field of lines are, magnetic lines of force are in this direction. Okay, this is the direction. Look again. Look again here. See, if the wire was coming, the current was coming up, then the magnetic field of lines are like this, the way I have shown the arrow. Okay, you can see it. Now here the current is going down. The current is coming up like this and the current is going down. So if the current is going down, again I hold my hand, like this, and if I am drawing these circles, again, look again, if I am drawing the circles like this, okay, then this is the direction of the magnetic field. Alright, okay. Now let me complete the diagram. So this is one circle, this is one line of force. All the iron filings will arrange themselves in such a way that they will make concentric circles. Their centers will lie on the wire, the ring, and in the center of the coil. I am coming back to this. See what happens in this region. This region is very important. If I see the arrows, all of them, the lines of force are in the same direction here. Now what is this here? What is this point? This point is nothing but the center of the circle, center of the circular coil. See, this was the center of the circular coil. So what has happened is that this portion produces its field, this portion produces its field, this portion, this, all these portions right here, all of them produce their own magnetic field as if they were straight wires. All this magnetic field is in the same direction as far as the center of the coil is concerned. So this is center of the coil, all of them are making field here. Not only that, these circles, they are concentric here. This is the center of the circle. The circles are getting bigger and bigger, therefore here they are getting straighter. I told you that the circles get straight, more and more straight as the radius increases. So here these lines are straight, and therefore what is the final conclusion? Final conclusion is that at the center of the coil, this was the center, this is the coil and this is the center of the coil. At the center of the coil or the loop which is carrying the current, the magnetic field is in straight direction, showing same direction. Say straight line, it is in straight lines showing same directions.